Now let's look at the problem of simplifying square roots. Well, the key to simplifying square roots is simply that, well, let's just start with an example. Let's say you have the square root of 80. So to simplify a square root is what we need to do is we need to factor 80 into two numbers. So for example, 8 and 10 or 4 and 20 or 5 and 16. But 1 needs to be a perfect square. And the very first thing that you want to do here is make sure you memorize the first 13 or so perfect squares, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. In fact, if you're starting with this and you're having trouble with it, you might want to write down all the perfect squares, at least the first 12 or 13. So 7 times 7 is 49, 8 times 8 is 64. 9 times 9 is 81. Did I forget 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 100. 11 is 121. 12 is 144. And 13 is 169. So what we're going to do is we're going to take 80 and we're going to split it into two numbers. But one of them needs to be a perfect square. Now 8 and 10 won't work, right? Because neither 8 nor 10 is a perfect square. So let's look here and see if there's any other perfect squares. Where 4 works, so we could break this out into 4 and 20, and then you have square root of 4, square root of 20. Now the reason that simplifies is because since 4 is a perfect square, the square root of 4 is simply 2, and you have 2 square root of 20. And that's how you simplify square roots. Now, we're not actually done yet, because even after you simplify it, you still have to look at what's underneath the square root sign, in this case 20, and you have to say, is there any numbers, any perfect squares that divide evenly into 20? And in fact, 4 does. So we can break it up into 4 and 5 again. So that becomes 2, square root of 4, square root of 5. Square root of 2 is 2, so that's 2 times 2, square root of 5, which is your final answer is 4 square root of 5. And that's the basic idea of simplifying square roots. Now, this problem could have actually done much quicker, because the square root of 80 is actually the square root of 16 and the square root of 5, right? Because 80 breaks up into 16 and 5. And the square root of 16 is 4, so your final answer is 4 root 5. It doesn't matter which way you did it. This way is faster, but you get the same answer. Let's look at another example of simplifying square roots. Let's say you have the square root of 175. So the first step that I need to do is I need to find two numbers that multiply to 175, but one has to be a perfect square. So let's look at my perfect squares. 4, 9, 16, 25, 36. I want to look at a number that goes into 175. If I'm not sure that 4 does, it turns out it doesn't, because you know it'd be even. But let's say I wasn't sure, so I go 175 divided by 4 and see if I get an even number. And I don't, I get a decimal. So I think 25 does, and I can do that on 175 divided by 25 is 7. Right? That's just 7 times 25 or 7 quarters, right? So that's square root of 25, square root of 7. And square root of 25 is simply 5, so that's 5 root 7. Now let's look at another one. Let's simplify minus 3 square root of 700. Well, the first thing we do when we have that, initially we just ignore any number that's outside the radical sign. What we have here is square root of 700. 4 goes into 700. 25 goes into 700. But the largest number, if you look at the largest number of all of these perfect squares that goes, it's going to be 100. So that 700 is 7 and 100. So that's square root of 100, square root of 7. Square root of 100 is 10, so that's minus 3, 10, and square root of 7. Now, when a number comes outside of the square root, it's multiplied by whatever number's already outside of there. So that's minus 3 and 10, so that's minus 30, square root of 7. And that's your final answer. So what could go wrong here? Well, one thing that could go wrong is you get a number that's so large that you're not sure what goes into it. So let's look at 324. I think that 4 goes into 324. Let's see. 324 divided by 4. 324 and 24, that's 81. So that's 4 and 81. So that's square root of 4, square root of 81. Oops, square root of 81. Square root of 4 is 2. So that's 2 square root of 81. But square root of 81 is just 9. So that's just 2 times 9, so 18. It turns out that 324 is just 18 squared. I didn't recognize it. Let's look at square root of 426. What's different about 426 and 80? The only difference is 80 I can easily do in my head. 426 I can't. But I do the same idea. I find one of these numbers that go into 426. And I could obviously do 4, but let me see if a larger number goes into. What about just what you do is you just think of a perfect square that's plausible. I think that 16 goes into 426. So what I'm going to do is I go 426 and I divide it by 16 on my calculator. And if I get an even number, an integer, then that means it works. This one doesn't work. So let's try 9. 426 divided by 9. No, 426 divided by 9 doesn't work. Let's try 4 and 9. It looks like there's not going to be anything easier than 4, so let's try that. Let's go 426 divided by 4. And that doesn't go either. This is actually kind of strange. 426. I know 2 goes into it, right? That's 2 and 208. No, 200 and... Let me just do that on a calculator. 426 divided by 2, 213. And then I'm going to spend a lot of time trying to figure out if I can simplify square root of 213. I can't. This is actually what's called prime. That's as simple as it gets, right? So if someone asks you to simplify that, that's in simplest form. It's easier to see if it's something like square root of 30, right? Square root of 30, there's no perfect square that goes into it. Anyway, let's do one more. Let's simplify square root of 180. So what I could do here is, I think that 4 goes into it. Let me check. 180 divided by 4 is 45. So that's square root of 4, square root of 45. So that's 2 root 45. Now, that's not a wrong answer, but if the question is simplified, that's not simplified. And because is there any perfect squares that go into 45? Let's look at our perfect squares. 4, 9, 16, well, 9. 9 and 5. So that's 2 square root of 9, square root of 45. I'm sorry, square root of 9, square root of 5. Square root of 9 is 3, so that's 2 times 3 root 5, or 6 root 5. It turns out with that one, I could have done a little bit quicker. If you have square root of 180, and I think actually that that's 9. I think 36 goes into that. Let me try that. 180 divided by 36. Yes. That's square root of 36, square root of 5. Now the key here is you don't have to just guess which numbers go in evenly into 180. I thought that I thought that 36 went in evenly into 180, so I just tried it. I just went 180 divided by 36 is 5. So it's 36 and 5, so that's 6 root 5. What do we have to be careful with? The key is that if you get something that looks like this, if it says simplify square root of 180, then the answer that they want is 6 root 5. They don't want you to use your calculator, though. You can use your calculator as a tool. If they say evaluate with a calculator, that's just simply a matter of calculator. Then that would be a problem where you go like this. You simply go square root 180. I'm going to do 180 raised to the 1/2 because I can't remember where the square root button is. It's about 13.146. You want to make sure if it says simplify, this is the answer they want, not a calculator answer, decimal answer. And that's how you simplify square roots.